Alright guys, Midwest Chem, back at it again. We're here for our quick one. This one's an easy one, also kind of an interesting one. So here we have 54 grams of mandelic acid and 54 grams of potassium permanganate. There's 27 grams of potassium carbonate in there. And we're cooling it down, and the reaction will be held at between 0 and 5 C. So a little slow, but we'll get there. Alright, here we go. Right now we're sitting at about 2 C. So we're going to do our first addition. Boom. Alright. It is a little slow because we're cold and under basic conditions. So let's give it a moment. The first one's usually one that takes the longest. Come on. There's a small temperature increase. It will start to slowly turn around. That red color is already kind of starting. I got too much water in this. Anyways. Hey, look at this nice burn on my hand. Pretty sweet. Didn't start with a thermometer. We know. Yep, getting a temperature increase, so we'll just kind of do this over and over and we'll come back. We're at 50 mils in of solution added, and the smell of benzaldehyde is evident. Not super strong. If you waft towards yourself, you will smell benzaldehyde. Which leads me to believe the diketone of glyoxylic acid, or phenylglyoxylate, somehow right now is breaking apart and producing benzaldehyde, which will produce benzoic acid in the final product. And that was to be expected. So we're going to keep it between 0 and 5C to try to minimize side reactions. But things are reacting a lot faster now, so that initial induction period's a little annoying, but get past it. Alright, we're getting a little messy. We got our Kool-Aid bath here. I wouldn't drink that, but I might. We'll see. Anyways, got my spinny beaker here. Good for rapid cooling. Anyways, the small batch ended up kind of taking forever due to temperature spikes, but this is actually going like really well. So maybe just the bigger surface area for cooling is helping. But yeah, we're gonna get through this real quick. Have you ever just thought to yourself, dichromate really isn't that bad? I mean, look at all that manganese dioxide. Somebody save me from this nightmare. Oh, it's nice and clear though. Hey. Alright. There's the manganese dioxide. Letting it settle. I washed it pretty good, but I'm going to wash it a couple times and decant. Just to really clean it up and save it. And there's the rest. So. Evaporating it down. As we get to the bottom, kind of light yellow solution. It's very light. But I think it was Sigma Aldrich I saw on their website said potassium phenylglyoxylate is a light yellow solid. So I'd imagine it would give a light yellow solution. I know that's kind of linear, like simple thinking, but yeah, it's probably the case here. Alright, so we got the alcohol acetone evaporated out and the water evaporated down probably a little farther than we need to. This stuff's not super duper soluble in water, I believe. So if we come on over here, let's check our pH. Slightly basic. I'm going to say excess potassium carbonate. So we'll probably see a slight fizzing and then the reaction will occur. Again, another thing to note is the light yellow color. I know I mentioned that, but it's definitely kind of how you're going to realize if you've got all the manganese dioxide out that you have potassium phenylglyoxylate. Now let's get some acid ready and precipitate this. First addition. Oh hey. That's cool. Wow. Just, I don't know, they're like flaky crystals. That's really interesting. Huh. Alright, well clearly it's not very soluble. Or is it? Okay, well, we only added a tiny bit, so we're just gonna keep going. There's a little CO2. So definitely we still got some carbonate in there. Once we get rid of that, these should hang around. This time I added about 10 milliliters. Oh yeah. It's like we're almost there. It's slowly dissolving. Ooh. Yeah, it's still dissolving. Alright. Definitely, I think an impurity in this is benzoic acid. I don't know how much of it's going to be an impurity. But definitely is going to be one because I smelled benzaldehyde. And under oxidizing conditions with permanganate, it's going to benzoic acid, period. So. Yep, looks like we've reached a point where we've got rid of the carbonate. Let's just dump it. Wow. Okay, we're getting a little on the fluffy side. I think there might be a little more carbonate. Not exactly sure. Very fluffy. Woof. Alright, here we go. That last dump really did it. We're at about a 2. So, this stuff is... there's more in there, kind of like precipitating out. But, it's like foam. It smells interesting. Very light smell. That's hard to describe. Huh. I wish I could give you guys a description. That is, I want to say like new car ozone, fresh air, sort of. I don't think that's correct, but... Yeah, and as we can see down here, there's even more precipitating out. I don't know if it's precipitating or separating. I think it's precipitating. Yeah, absolutely. I wonder if we can recryst this. Let's give it a shot. Well, this is interesting. Now, I'm wondering if this is benzoic acid and this is phenylglyoxylic acid. I'm facing an issue, though. There's claims of about 1 gram, 920 milligrams per milliliter. And I just don't understand if that's true. This is very interesting because this is definitely less dense. This is more dense. Or maybe just the way it precipitated. Maybe these are finer crystals since they pooped out immediately, and these kind of precipitated so they're heavier. I'm not really sure. I mean, if I got a 60% yield, I should be at about 30 grams. This is interesting. Let's get stupid for a moment here. And if we do this, melting point of phenylglyoxylic acid should be about 60 degrees. And I was able to get some of it to melt and run off here. Yeah, I don't know. Alright, got everything heated up. We're going to try to recryst. So, let's see what it is. I don't know if you'll be able to see it, because I've barely been able to see it, but I caught it. The density lines. I caught a very small bit of it. And I think that's a good sign. So the melting point's about 66°, and I brought it to boiling. So if any's precipitating out early, it's going to be as a liquid because it's molten. Oh boy. Come on. I don't think I'm going to catch. There's actually that interesting aroma in the air. But I'm getting ready to leave. We're possibly going to be involved in an ice storm. Sorry, my fingernails are dirty. I've been working all day. Yeah, we're possibly going to be involved in this ice storm right on the edge of it. So definitely hoping this is wrong, but I wanted to get a little shot here before I left. I just think this is absolutely gorgeous. Look at those crystals forming on the bottom. Oh, they're so shiny. Really is looking like benzoic acid, though. But phenylglyoxylic acid and benzoic acid should have fairly similar crystal structures. I mean, phenylglyoxylic acid is a diketone. I just don't know. Regardless of what it is, that's beautiful. I have a nice camera. I wish I'd take the time to learn how to use it. Not very technologically literate, though. Here we are. So we got some crystals. It's actually still a little warm, but I'm gonna disturb them. Look at that. It's very weird how it sparkles like that. It looks like little dots shooting around. Or like something, I don't know. It's very cool. It's about 65. And it is melting. Not very much, but it is. It's recrystalline on the side when it's not molten anymore, so. Let me get this. Oh, yeah, kind of. Yeah. I forget what those lines are called. They're density lines. Yeah, you can kind of see them moving around in